Let's now dig deeper into the cloud infrastructure part, starting with networking. Just as we mentioned before, we will need to configure and use multiple networking services when running in the cloud. Each cloud provider has its own terminology for such services, which may complicate it a bit. For example, our cloud instances or VMs will need to connect to the internet, and depending on the public cloud or clouds you choose, you may need to configure VPCs and IGWs in the case of AWS, VNets and routes in the case of Azure, and VPCs on Google Cloud. Then, we will need communication from branch offices or other on-premises data centers to the cloud. And in order to do that, we may be using VPN connections or even dedicated physical connections from each cloud provider. Connecting through VPNs will include different terms such as TGWs and VGWs if you're using AWS, VPN gateways in case you're using Azure, or Cloud VPNs if you're using Google. In any case, you can also run a Cisco CSR1000V instance on the cloud to terminate VPN tunnels if you'd prefer. And if you use a private physical connection to the cloud, other terms such as AWS Direct Connect, Azure Express Route, and Google Dedicated Connect will come into place. We will be covering this and many others in detail along the module. This is just the beginning, since we will need to use and configure additional services such as server load balancing, DNS, and content delivery networks or CDN, just to name a few, all with their own cloud-specific names. Cloud networking usually gets charged by the service, the public or elastic IP addresses you use, and the amount of data transferred. Now, if we move to the compute layer, and as said before, each cloud will use its own hypervisor version when VMs are used, whether that's customized SEN, Hyper-V, or KVM depending on the cloud. Remember that unlike the network, the cloud hypervisor is not visible to the user and does not require any configuration. On top of that hypervisor, organizations will run instances or VMs, or you could also have dedicated bare metal instances running on the cloud if you prefer. AWS has a service called EC2 to deploy such instances, while Azure has Azure VMs and Google delivers Compute Engine VMs. All of them will run an operating system or image on top of them. There are multiple instance types based on the performance needed, the amount of memory assigned, and even the special adapters they may use. All those choices will directly reflect upon your build, and there are options that may make them less expensive, such as reserved instances, which allow you to commit to a specific period of time at a lower cost, spot instances, and many others. Finally, we need to store information somewhere, whether to boot our instances operating systems or for file, object, backup, and even archiving purposes. In this case, you will commonly be charged by the service, the type of storage, and protection mechanism you choose, as well as the tier, which is based on the frequency you expect information to be accessed. Covering the instance types and storage offerings in more detail is out of the scope of this series. If you want to learn more about this, cloud training and certification exams such as AWS Architect Associate, Azure Fundamentals, or Google Cloud Engineer are a great way to start. Security is equally important to all these layers as mentioned before. The physical access to cloud provider buildings and their physical infrastructure are secured and managed by the cloud provider itself. Therefore, you do not need to worry about that. However, the level of security on every service and instance you deploy will depend on you as an administrator. Multiple companies have gotten hacked even when running in the cloud, so this is a key topic for organizations to address early and often. Although not the only ones, some of the most important areas we need to know about as network and infrastructure administrators are 1. Authentication. Opening a cloud account is extremely easy. As long as you have an email, credit card, and a password, you're all set. You should be able to access your cloud console with such credentials as the root or main user. Just like with on-premises, you may add additional users to access such account. Therefore, using role-based access control as part of your organization's authentication model is highly encouraged. This is defined on IAM or Active Directory based on the cloud of your choice. If we take a look at AWS IAM, for example, you can create additional users with administrator levels for either console and/or programmatic access and assign different privilege levels to restrict access. Additional security options to access cloud consoles may include multi-factor authentication, which is highly recommended. Now, in terms of accessing instances or VMs you deploy in the cloud, you may require more than just a password. Public cloud compute services mostly rely on key pairs in order to allow access to such resources via SSH. A key pair consists of a private key and a public key and is used to prove your identity when connecting to an instance. Some cloud providers like AWS commonly store the EC2 instance public key, and then you just store the private key, which is usually a .pem file. You use a private key file instead of a password to securely access your instances. Anyone who possesses your private keys can connect to your instances, so it is important that you store them in a secure place. Creating a key pair is fairly easy. If we take AWS as example, you just have to go to EC2 and in the key pair section, just create a key pair by adding a name to it and then just store the .pem file. I can now go ahead and create a Linux EC2 instance, and as part of such process, I will have to specify the key pair I want to use so that I can access it later through SSH. My new instance is ready. It already has a public IP and public DNS name. So let's connect to it through our SSH terminal. I just have to follow the instructions provided, changing the privileges on my .pem file first, and then I can now SSH directly into my AWS instance with its default settings. Easy, right? In case a cloud instance or VM gets compromised, disabling lateral movement is a must. This is why network segmentation is so important. Since there are no VLANs in the cloud, classification and segmentation are often done based on subnets or attributes, and communication between different segmentation groups is commonly denied by default, requiring the creation of explicit rules to allow traffic between them. This is very similar to how Cisco ACI operates through EPGs and contracts. Instead of VLANs or EPGs, cloud providers use security groups and NACLs in the case of AWS, ASGs and NSGs on Azure, and firewalls if using Google Cloud. We will cover these in more detail in the next chapters. Then, just like on-premises, having L4, L7 services and advanced security and vulnerability detection features may also be needed. Although some of these may be provided by some cloud-native services, organizations may choose to implement their own solutions directly on the cloud. As a summary, cloud is here to stay. Adopting a cloud operation model, whether public, private, or hybrid, allows organizations to increase agility, flexibility, and scale. However, it brings multiple challenges in terms of multiple terms and toolsets for each cloud, which may reduce the ability to provision and manage services faster in a consistent and automated way. IaaS, PaaS, and SaaS provide great benefits, and all the different types of cloud-native services can definitely help to accelerate innovation. Keep in mind that it is extremely important to include security, high availability, and monitoring as part of your cloud design, since it will help you minimizing any potential downtime.
ACI provides you with a better, simpler, and secure network, any size, anywhere, and on any cloud. If you want to learn more about other common tasks and how ACI radically simplifies network provisioning and operations, please watch the rest of the videos in this series. Thanks for watching.